Alright guys, so if you're going to run a chi-squared test, goodness of fit test in SPSS, what I suggest doing is loading SPSS. Start by going to variable view. Let's create two variables. The first I'm just going to call category, and the other I'm going to call frequency. So at this point I should already know what my categories are and how many cases I have of each category. The example we used in the video was if we had asked how many of our students were in fraternities or not, and we knew we were going to classify people as either being a fraternity member or an independent. So for my category variable here, I'm going to go ahead and add value labels so that I'm going to classify fraternities as having a value of 1, fraternity, and independence as 2. And then those labels are added, then I'll just hit OK. You should see your labels turn up here. Then if you go over to data view, I'm going to say, okay, for category 1, my fraternity members, I said out of my 26 students, 19 were in fraternities. And of my independents from my class, I had 7 of 26. I entered a 1 and a 2 here, but remember I've labeled these, I've attached value labels, so if I go to this symbol, I can swap over to the actual labels to make sure I've entered them correctly. Okay, so at this point then, the next thing I need to do for a chi-squared test is to let SPSS know that for this data, what I really want to indicate is there are 19 people in a fraternity and 7 people in the independent group. So if you go up to data and drop down to the bottom to weight cases, then what we're going to tell SPSS to do is to weight the cases by the frequency variable. And so this will tell SPSS that instead of just having 2 individuals or 2 observations, I actually have 26, the total of my frequency variable. Should see some output turn up there. And at this point now you can run your chi-squared test. I think your text may or may not run you through how to run through using the newer versions of the SPSS dialogues. I'm going to ask that you use the legacy dialogues in SPSS and go down to chi-squared. So under Analyze, go down to non-parametric tests, legacy dialogues, chi-square. Now you need to tell SPSS what's your test variable. That variable is category, which you'll move over. Frequency we're not going to use, you just use that to weight the cases. If you want to run the same test that we did in the video, or that I ran you through in the video, where we ask, are the numbers of fraternity members and independents equal, or did they come from a population, or what's the probability they came from a population with equal numbers of fraternity and independents, then you can leave the expected values here set to all categories equal. So that uses the null hypothesis that there are no differences among any of the categories. If you hit OK, then you're going to get a relatively compact output. SPSS will show you for your category variable how many people were in the fraternity group, how many were in the independent group, the total, the expected number, so 13 in each case, and the difference. So this should fit exactly with what we did in the video. And the overall chi-squared statistic was 5.538. We had 5.54 in the video with 1 degree of freedom, and the probability for that test that this sample came from a distribution with equal numbers of fraternity and members and independents is 0.019. So with an alpha of 0.05, we would reject the null hypothesis and conclude that in fact the percentages of fraternity members and independents is not equal, and there are likely more fraternity members than independents. Now, I did say also in the video that if we knew that on the Wabash campus 60% of our students were in fraternities and 40% were independents, we could use this as our null hypothesis. In SPSS, this is easy to do. Just go back to Analyze, back to non-parametric tests, and then back to legacy dialogues, and then over to the chi-squared option. The only difference is under expected values. Now you're going to indicate that you know what the values are, and you need to enter these values in the order that your category variable goes. So that the first value I'll enter is for category 1. So I said that there's 60% of my campus are fraternity members, and I coded fraternity as a 1 in the category variable. So I'll put 0.6 here for 60% in the values. And for value 2, that's my independence. And I said I had 40% of my campus were independents. Okay, and that's all you need to do, but you need to make sure these are in the right order, or else SPSS will make the wrong comparison. Okay, so now the only difference here in the output, you still have the same 19 fraternity members, 7 independents. The only difference is instead of 13 members or 13 individuals expected in either category, now because we know that there are 60% of our students are fraternity members on campus, then we expect 60% of our 26 students to be fraternity members. And so 26 times 0.6 gives us 15.6 students for the fraternity members, and 40% of 26 gives us 10.4. So while our observed frequencies are whole numbers here, because you can't have half of a student, half of an independent, or half of a fraternity member, for the expected frequencies you can have fractions. And so you will not round these up to whole numbers. You'll let these stay fractions. And so now my residuals, the difference between the observed and the expected, is smaller. Remember, it was 6 and -6 for our first test. But now, because the expected proportions are closer to what our sample showed or obtained, then these differences are smaller. And so in the end, the chi-squared statistic is smaller. It's not 5.5, now it's 1.9. And if you remember, for 1 degree of freedom, the critical value for chi-squared for an alpha of 0.05 was 3.8. And so this critical value, this obtained chi-square statistic is less than 3.8, and so now we will not reject the null. So if in fact 60% of our campus is fraternity, or is a member of a fraternity, then it's not unreasonable. We would expect that if we pulled 26 students out at random, we could get a distribution that is this skewed towards fraternity members about 17% of the time. So this would be an entirely normal sample, or typical sample to pull out of our distribution. All right, and that's, I think, it for chi-square goodness of fit.